Hello. Hi, everyone, and welcome to United Astronomy Clubs of New Jersey. Thank you for everyone who came out on this gorgeous night. It's absolutely crystal clear. We had actually just seen what we believe to be the SpaceX rocket that launched a bit earlier, so that was fun to see. I want to welcome everyone here. I see a couple people wandering down, so while they're just going to find their seats, a couple quick things. You can always check us out on our website, uacnj.org. That's where you're going to find a list of all our upcoming programs, a list of our member clubs, and anything we might be doing that's interesting. We do live stream this, so you can check us out on our YouTube. Please do like and subscribe, because we like you guys coming back. With that, you can also check us out on our socials. We got Facebook, Instagram, Twitter, we got a Discord channel. As well as something else that I forgot about. So, must not be that important. Moving on. Now, for those of you who are here, a couple real quick safety things. If you need to use the bathroom, that is the porta potty to my right, your left, lit up by red. We do have a little gift shop and museum area to my left, your right, outlined in red. And I will be there after stream. And you can just check out all the literature we have, as well as, like I said, our little museum shop. We do have multiple observatories. Some of them are open tonight. And that is where, after the stream, we'll be observing the night sky. So, what are we doing tonight? We are going to learn about Antarctica and the South Pole Telescope with Gil Jeffer. Gil is spent 20 years as a senior scientist for M&M Mars, concentrating on the adaptive technologies, and he had retired in 2006. He began work as a research engineer for the Center for Solar Terrestrial Research at the New Jersey Institute of Technology in 2008, and has had eight, right? Eight. I didn't know whether I lost count somewhere or not. 8 working trips to McMurdo, the South Pole, and remote locations in Antarctica, beginning in 2012. Former longtime observer and board member of UACNJ, here's Gil.
Thanks for coming, everyone. Really appreciate you being here. Well, tonight I'm going to talk a little bit about the South Pole Telescope, which wasn't one of my projects. And I'm going to talk a little bit about working in Antarctica, going there, traveling there, what it's like to be there. I find Antarctica to be an absolutely wonderful, beautiful place. Just the desolation itself is amazing. It's as close to being on another planet as you can be without being on another planet. It's just so much different than here. So tonight we'll talk a little bit about the South Pole Telescope. It's a pretty amazing piece of machinery, especially when you consider they had to build this thing in Antarctica. And to build it, you had to bring it down on C-180s, or C-1 planes. LC-180, yeah. And those planes can fit 8 by 8 by 16 feet is the maximum size you could fit in it, and 26,000 pounds. So this telescope is 33 feet in diameter, and there's a lot of infrastructure, too, that had to come down with it. Why go to the South Pole to do something like that? Why not do it up here? Well, there's some main reasons. One is it's very dry. Antarctica, for the most part, is really a desert. The precipitation is very light. There's hardly any. Water vapor is very light. No atmospheric moisture, and it freezes out in the extreme cold. The other thing is it's very dark. In the winter in South Pole, you don't have daylight and night like you do here. It basically, the sun goes down, sun stays down, you have about 6 months of darkness, and there you go. Then it's daytime again. When it's daytime again, daytime is 6 months. That's when you can work on things and get them ready. That's when I traveled down there. I traveled down for our winter, their summer. The seasons are swapped. It's very stable. There's no fluctuations in the atmosphere to disturb measurements. Since the sun's not going up and down, the atmosphere basically stays very still, which is nice. And you have the same sky. Here you're watching the sky. It goes overhead and sits over there. There you have the same area of sky overhead all the time. It turns as the Earth turns, but it's the same spot in the sky all the time. So you can study the same area for days and days and days on end without changing it. What was the main purpose of the South Pole Telescope? It was looking at the cosmic microwave background radiation that's in the sky. Penzias and Wilson in 1964, right here in Homedale, New Jersey, discovered it. They didn't know what they were looking at. They built a big antenna. They were looking at the transmissions from the Echo satellite at the time. And that huge microwave antenna, they pointed at the sky and pointed it in many different directions. But they found out that every direction they pointed it in, they'd get interference. They couldn't figure out what they were hearing, this noise they were hearing. And they went on and tried to clean things out of it. They actually even cleaned pigeon droppings out of it. They, did put tape over the joints in it and everything else, but it still happened. In the meantime, in Princeton, a couple of scientists were saying, cosmic microwave background radiation, we should have some microwave signature of the birth of the universe, and it should be able to be detected in a microwave range. And they got together to Penzias and Wilson, basically contacted the people at Princeton, and lo and behold, the people at Princeton said, we've been scooped. They found what we thought was going to be there. Penzias and Wilson got the Nobel Prize. Peebles and Wilkinson, who were the ones that predicted it, did not. So the Big Bang, 13.7 billion years ago, put a plasma out when it first happened. There was an inflation and then a plasma in the universe. The plasma was free electrons and everything else, and photons could not get through that. So there was really no light coming out of it. And then about 330 or 340,000 years after that, it cooled enough that all of a sudden light could get through it. That's what we see as cosmic background radiation. Once it cooled enough that the atoms started to form, the electrons weren't free anymore, the plasma went away. So the universe has been stretching ever since, and basically the signature from that Big Bang, from the when the electrons formed into atoms again, is seen all over the sky. The first images of it was that image you see in the lower right corner was 2 years of data from the Kobe satellite. South Pole satellite made a lot better images. So next thing is, why are you looking at microwave if it was light? Well, the spectrum of light really, the visible spectrum in the middle that you see there, what we see, the red, white, blue, etc., is one thing. As you go to shorter wavelengths, you go ultraviolet, X-rays, and gamma rays. As you go longer wavelength, you go to infrared, microwave, and radio waves. Since the universe is expanding, you get a Doppler shift, just like you do when an ambulance passes. You hear the low sound of like that as it goes by. Well, the same thing happens with light. It stretches out the wavelength. That light is stretched over into the microwave area. And that's what this South Pole telescope is able to detect. So that first one from Kobe, you can see, was rather crude. Planck satellite basically made a much more detailed map. But when you look at the latest images from the South Pole telescope in the lower right there, you see a really phenomenal image of detail. Now, the one thing there, you see a lot of different colors. It kind of implies that there's a lot of different temperatures. It must be a very big difference. But if you look at the temperature, it's 0.000002 degrees Kelvin, which is degrees Celsius too, as far as the width of the degree, differences between these colors. So very, very tiny, tiny differences. But those tiny differences are really important, because if it wasn't for that, we wouldn't exist. These tiny differences during inflation and gravitation basically is what caused all the different, so we're not completely uniform, caused planets, galaxies, stars, everything to form. The SPT, the South Pole Telescope 3G camera, has a definition of 1 arc minute. Now if you hold your finger out, your little finger, at arm's length, that's about 1 degree. The difference between one side of your finger and another. An arc minute is 1/60th of that, just like degrees minutes. So it's 1/60th the width of your little finger held at arm's length. So that's the resolution of that. It's pretty amazing. What questions do they want to answer with the South Pole Telescope? Well, a lot of things. Basically, how old is the universe? Well, 13.7 billion years is what we figure. What kind of atoms are in there? What kind of things make it up? How does it work? How will it look in the future? How is it aged? You hear about dark energy, dark matter. They're pretty new as far as on the horizon what happened. Um, how does that fit into it? What can we detect with it? What does it look at? We have seen a lot of pictures of the Hubble, and a Hubble looks at you had the deep field. In this picture here, you're looking at what was a dark area of the sky, but with a long exposure on the Hubble, and almost everything you see there is a galaxy. There are hundreds of billions of galaxies in the Milky Way alone, and there are hundreds of billions of galaxies that all have hundreds of billions of stars in them. Um, Basically, it's hard to comprehend the vastness of the universe. But you think the Milky Way alone, if the Milky Way had 1 million inhabited planets in it, and they were uniformly distributed around the Milky Way, it'd be about 200 light years to get from one planet to another. That's just the Milky Way. Now, mind yourself, there's hundreds of billions of galaxies, and each of those have hundreds of billions of stars in them. So it's pretty amazing what you're looking at. But what the South Pole Telescope is looking at is not this. It's looking between these. It's looking at the dark stuff in between. It does not look at galaxies, does not look at stars, it does not look at nova. It looks at the dark space in between, because back there is the microwave radiation from the Big Bang. So how did the galaxy form? Well, there's a lot of theories about it, but basically there's the Big Bang, and then at 10 to the minus 32 seconds, there was inflation, where the universe expanded almost instantaneously. It expanded by 10 to the 30th power from where it was. So it started out as a very small area, and just all of a sudden, wham, like that, very big. One of the things that the South Pole Telescope was doing is trying to detect, is that theory true? Did that inflation really happen? But after that, you can see where it's all the purplish colors. That is where no light was available, because you just had a hot plasma of electrons and particles. After that is where the Big Bang basically is at that juncture between the purple and a black, and that's when we're looking at when we look at the cosmic background radiation. Another way to look at it is this. Basically looking at other things in the galaxy, the dark energy and the dark matter. Where basically 4.5% of the universe is regular matter, the stuff we're standing on, the air we breathe, the stars in the sky, the trees, everything else. The rest of it isn't. About 22% of that is dark matter. Why is it called dark matter? Well, because we can tell it's there because of its gravitational attraction on objects, but we can't see it. We have no way to really detect it yet. And then dark energy, 74% of dark energy is the universe. Dark energy is what is pushing things apart. It was lately thought that the galaxy was going to be pulled together by the gravity of all the objects in it. What they found out instead is the galaxy is expanding at an accelerating rate, faster and faster and faster. So gravity should pull things together, but dark energy does the opposite. It pushes things apart, even further apart at distances. And it causes the universe to expand at an ever-increasing rate. And one of the things they're doing with the South Pole Telescope is trying to put an upper bound on what that is. So to do that, they look at galaxy clusters was the first thing. Galaxy clusters are way deep in space, and the South Pole Telescope looked at 2,500 square degrees of sky, and it looked at the location, the size, and the distance of these clusters. All these galaxy clusters are kind of like a web, like a spider web, where there's dense parts in a web. The one cluster in the lower right there is 7 billion light years away and has the weight of 800 trillion suns, and there's hundreds of galaxies in it. By looking at that and seeing how those are all clumped together, we can get a limit basically on how much that dark energy is pushing things apart and how much it's holding them together. The clumping of matter and clumping together. How's the South Pole Telescope put together? Well, I mentioned it's really huge. It's 33 feet, 10 meters in diameter, and it's a really immense instrument. The interesting thing is putting it together at the South Pole. The South Pole is at 9,300 foot altitude. 9,000 feet of that is ice, and only 300 foot of continent. So basically, you're setting this thing that weighs 350 tons on ice and snow. To do that, basically, they packed the snow down really hard, the ice down really hard. Then they put a wooden base and then built this on top of it. All this has to be done during the summer season at South Pole. The summer season lasts at maximum about 3 months. So a lot of work to do very quickly. After years, it first saw first light in 2007, February 16th, and it's an amazing machine. The smoothness of the mirror is about 1/1000th of an inch. The mirror is made out of aluminum because it's microwave. It weighs 308 tons. The receiver, I'll get to that later. Basically, the rotation resolution is 1 arc minute. I mentioned what that is. Your pinky out, 1/60th of your pinky out at the length of your hand, and pointing within 1 arc second of accuracy. So this telescope is moving up, down, left, and right all the time, and it can scan at 4 degrees of sky per second. So full coverage of the horizon. Now, the one thing that's interesting about it is you're working at the South Pole. So in the winter, you're talking about temperatures that can get well below 100 degrees below zero. And wind chills that can be 150, 160, 170 below zero. So when you have to work on a telescope, they had to design that into it so you could, because you're not going to go outside and be tinkering around out in that weather. So it is set so that you can see that receiver cabin that actually comes down and hooks up with the roof of the building, and then from inside you can actually open it up and work on the telescope, and then close it up again, and out you go and observe again. The base of the telescope is shown here. There's a 9-foot bearing on it, 9 foot in diameter, about the width of the store, that telescope spins around on. Amazing thing was, about a year and a half, they were wondering why the telescope was making so much noise when they were moving it around. And about a year and a half after it came in, it turned out one of the bearings had been put in sideways. So these are roller bearings. They basically look like Coke cans, but like a squat Coke can. So you could turn one this way and it wouldn't be turning around. It would be against the rotation. So it was just scraping. So they're constantly adding grease to it and constantly seeing a lot of metal in it. So eventually what they had to do is actually replace the bearing in this telescope. It was put together wrong and when it was manufactured, not at the South Pole. So it was quite a project to lift that whole telescope up off the base, take this 9-foot diameter bearing out, and put a new one in. And they managed to do it, which I think is just fantastic. That mirror I mentioned is very, very smooth. Well, to do it, they made the telescope itself out of carbon fiber, and then they put spacers on it so they could adjust the aluminum plates that they put on top of it to actually a little bit less than 1/1000th of an inch, about 8/10,000ths of an inch. So the surface smoothness of that whole dish is accurate to within a diameter of human hair, which is actually pretty amazing when you're building something like that down there. A lot of planning goes into it. They also had to put a ground shield on it. You can see the structure on the side of the telescope. What's the ground shield for? Well, that's to keep it from getting reflections from the hot snow. What it's looking at are temperatures that are close to absolute zero. Cosmic background radiation is just a couple degrees away from absolute zero. So the snow, even though you're talking about really cold temperatures, here July 4th it was about 109 degrees below zero. You're talking about really cold temperatures. To that telescope, that's hot, which is pretty amazing to think about. So there's a picture with the ground shield in place. Now the telescope can look around and not get reflections off the snow or the heat. And then the camera is an amazing instrument too. They're on 3rd generation camera. That's the SPT 3G 3rd generation. The camera itself weighs 2,400 pounds. It also can read the polarization of the radiation that it's getting, not just radiation itself. It reads at 3 different wavelengths. Now, it doesn't look too impressive when you look at that. There's 16,200 detectors in it, which is 2,690 pixels, because there's 6 detectors per pixel. That's nothing. I mean, when you think about it. This screen is like 1080 by whatever itself. There's millions of pixels per screen. But these are very different pixels. They're reading fluctuations in temperature in micro degrees. And each pixel actually has to be built individually. So it's built, and then it works is by looking at it, keep it at a bolometer basically. So what it is it keeps these things in a superconducting state right between the point where they conduct and they don't conduct. So very minute changes in temperature cause great changes in resistance of these individual pixels, and that's how they are able to read the very small changes in temperature that you're seeing in the cosmic background radiation in that map that I showed you. So the camera is put into a secondary called a cryostat. And that's kept at 10 degrees Kelvin. 10 degrees Kelvin means 10 degrees above absolute zero, so about 440 degrees below 0 Fahrenheit. That whole instrument is kept at that temperature, and then they lower that through that hatch in the ceiling. That's the white instrument that you see there, and the camera, the red instrument, is put into that to cool it. The camera runs at about 1/4 of a degree above absolute zero. Keep the noise down on it. And here's a picture of how they do how once that is lowered over the dome, how they're able to open it up and lower with chain hoists, lower the secondary down to work on it. And then it's set up, cameras put in it, and it's set up as charging to keep it cool it down to work on it, so it can be put back together again. Excuse me for a second. Calibrate it, there's the calibration target that's 2 miles away. And to calibrate it takes about 40 hours to calibrate each of those individual pixels in that camera. And in the middle of this big square dish there, it's kind of pointing at the sky, it's angled so that you're not getting the reflections off the hot snow, is a 1-inch square little heating element that heats very slightly, and that constantly spins the rotation of polarization so they can detect that and calibrate their cameras with it. One of the really neat things they did with the South Pole Telescope is it's part of another telescope that's the size of the whole Earth, and that's the Event Horizon Telescope. The Event Horizon Telescope is put together with 7 different observatories around the world, and that's to look at deep space, to take a look at black holes, and actually try to get an image of a black hole. So that has 25 micro arcsecond resolution. Now I mentioned that if you took your pinky, an arc minute would be 1/10 of what is your pinky, the width of your pinky. 25 micro arcseconds is about 5/10,000ths the width of a redhead's hair at arm's length. Now, though I made those calculations, so you may want to check my math on that, but I think I'm pretty close to it. But amazingly fine resolution. So the first thing they did was look at M87, and in the center of M87 is a black hole. They were able to detect that, the massive black hole at the core, and M87 is a really strange galaxy. It's bigger than the Milky Way, but more importantly, it's about 200 times more massive than the Milky Way. And at the center is this black hole, which is about 6.5 billion solar masses. And that black hole, basically the event horizon on that black hole is about the size of our solar system. So that was the first one they were trying to image. And they did. In April 2019, that's the first image of a black hole. Obviously, you don't see the black hole. What you see is the gas spinning around it at very near the speed of light as it's going around and around and around and glowing because it's spinning so fast and ionized. So it takes between several days to a week for that gas to make it all the way around, spinning around the galaxy, or spinning around that black hole. It's absolutely amazing. The resolution of that is 20 micro arcseconds, and as they put it, that's enough to read a newspaper in New York City from a cafe in Paris from New York City. It's amazing resolution. The second thing they did was take a look at the black hole in our galaxy. Now, our galaxy is much smaller than M87. It's much less massive. So this is 4 million solar masses, and it takes about 27,000 light. It's about 27,000 light years from Earth, and the gas going around that takes minutes because it's so small. And as they put it, I love this too. From Earth, I love equivalents like this. So when people say things weigh, 100 elephants or whatever else, I love that. I just absolutely love it. So they say that appears to be the same size as a donut would be on the moon. If we were looking at a donut sitting on a moon, that's about the size of this. So that's about as much as I'm going to tell you about the South Pole Telescope. Like I said, it's not my project. I don't know much about it, but I just find it a really fantastic instrument. Amazing that it was built down there. Amazing that it's operating all the time in the winter. It's really great to see, and it's really getting some really phenomenal science discovered with that. So Antarctica itself, what's that all about? Well, I've worked there for 8 years. In the summers, like I say, the warm part. When I get down, it's usually about 40 below zero. So and it warms up. On warmest days, you'll get up close to zero at the South Pole. So it's not bad at all. Um, Not many people think about Antarctica. When you look at a map, it usually looks like that little bit on the bottom, like a coffee stain. But it's a really huge place. It's about 1.5 times the size of the United States. And once in the winter, the ice around it, it makes it much, much bigger than that. So it's a huge continent. A few facts about Antarctica. First off, it's cold. Yeah, record low 100 minus 128, and that's the record low because that's the official one. Up on Dome C, it's actually been colder than that, but it wasn't measured officially, so it gets very cold. The average temperature year-round, if you average the whole yearly temperature at the South Pole, is 57 below zero, and 97% of the continent is covered in ice, and it's really thick. As I mentioned, in the South Pole, it's 9,000 feet. In other places, it's a couple of miles thick. Very dry, which aids this South Pole telescope and a lot of other instruments that can't take the humidity. South Pole telescope is looking at a microwave. When you put a glass of water in your oven, in your microwave oven, and turn it on, what happens? It absorbs the heat. The water gets hot. Well, you're looking at microwave resolutions in the sky. The moisture in the sky is absorbing a lot of that microwave. So that's why you want very low moisture. Very windy. The highest wind speed recorded for sustained wind, not gusting, is 218 miles an hour. But actually, I have a video near McMurdo where it was 223. Vostok, a Russian station, the average year-round wind there is 50 miles an hour. Very high, 6,500 foot average elevation, and much of it is higher than that. And it's also very sparsely populated. So the remote sites, like where I worked, there were 3 to 4 people. But at summer at South Pole Station, there's about 115 to 140 people. In the winter, only about 40. So you really, everything has to be very well planned. You have to have everything together. And when you go down there, you don't want to forget anything because there's no Home Depot to go to get it. How to get there? There used to be a lot of crazy flights that we used to have to go actually to Sydney, Australia, and then cross over to about 1,000 miles out of the way, and then cross over to Christchurch, New Zealand. But now they've gotten direct flights from United States to Christchurch. It's about a 16-hour flight, quite a long flight, and then you take the commercial flights to get there. And once you get there, then you take flights from the Air Force or the Air National Guard to go further to get to Antarctica. Where do we go? Well, the yellow dots are stations. Concordia is the Italian-French station, which became part of our project 2 years ago. The blue there are the places that I work out in remote areas of Antarctica. They're pretty far away from everything else. And the other 2 yellow dots on the left, there's McMurdo to the south, and the South Pole is the yellow dot kind of towards the middle of Antarctica. The magnetic South Pole is different than the geographic South Pole. The geographic South Pole, that yellow dot, is the axis of the Earth. The magnetic South Pole, what your compass actually points to, or actually away from, when you're looking at the South Pole, is actually off the shore of Antarctica. It's in the ocean at this point, and it moves. It's been moving over the years. So it's kind of an amazing thing to do. To get to McMurdo to South Pole, that's about 840 miles between those 2 dots. The first thing we do is when we go to New Zealand is get clothing that we need for Antarctica because it's cold. So you get your emergency cold weather clothing. You get on a plane. You have to have all this stuff to get on the plane to get down there. You have basically a balaclava, coat, jacket, hat, overalls, boots, very nice warm boots, gloves, the whole bit. You're all set. And you have to have these on a plane. You have to be wearing them, but you don't have to wear the gloves or the balaclava while you're on the plane, but you have to show it to them that you have it. And there's a reason for that. The plane itself can be extremely crowded. As you can see here in the picture, this is one of the most crowded flights I was on. We actually had to interlace our legs. We were sitting face to face like this, the legs just interlaced together. It was pretty amazing because it's a long flight. If you're on an LC or a C-130 flying down there, it's about 8.5 hours to get there. And you're flying like that the whole time. And when you have to go to the bathroom, you literally have to climb over other people to get to it. It's kind of amazing. And your seats are basically nylon webs that you're sitting in. Flights to McMurdo can be kind of odd too because you don't always make it. Last time I went, we had two boomerang flights, basically where you start flying, get partway there, and then the weather turns bad in Antarctica, and they say, well, we got to turn back and go back again. Because there's not a lot of airports you can land on. You're actually landing on the ocean, frozen ocean. So if there's no place to land, you have to get back. So they will go down to the point where we used to call it point of no return, but they thought that sounded too ominous, so now they call it point of safe return. And we actually quit 5.5 hours out, boomeranged, and 5.5 hours out, the pilot said was 10 minutes away from the point of safe return. So if we went another 10 minutes, we would have to go to Antarctica because we wouldn't have enough fuel to get back to Christchurch, New Zealand. So we tried for 3 flights, actually, 5 different tries, 5 times on the airplane, 3 times we took off and flew. The longest one was 5.5 hours out before we turned around. So 11 hours on a plane, and we ended up back at the airport where we started, crowded like that. It was really a lot of fun. No, it wasn't. Uh, but we did make it there, which was a good thing. Yeah, it's basically that round trip was 3,332 miles to get nowhere. So once you get there, you start flying. The first thing you do is fly over the Transantarctic Mountains. They're absolutely gorgeous. They're gorgeous mountains. They poke up through that ice, through that huge, thick ice sheet. And it's amazing just to see them. They look like something somebody painted rather than something you're actually seeing at the little portal on a plane. Your portals are about this big to look at, so it's real hard to actually do that. But you also start seeing all the glaciers, and glaciers are flowing through this ice all over the place. As the snow builds up, it gets heavy, it starts pushing down, and you end up with the glacier in a valley. But finally we landed. We landed at Willie Field. There's our C-130 plane that we landed on. And you're actually landing on frozen ocean. So that's 24 feet of compacted snow on 8 to 10 feet of ice, and you're actually sitting on 1,500 feet or 1,100 feet of water underneath you. They can land C-17s and C-130s there. C-17s are much bigger. Sometimes we get to take them down. They're really a pleasure to fly because a couple things. One, they're quieter. They don't shake as much. They're a lot newer, so you don't have people running around with flashlights checking all the hydraulics to make sure things aren't leaking. A lot more room to sit in them, and they're faster. They make the flight in about 5 hours, so that's really nice. But when you first get to McMurdo, it's exciting, but it's kind of a letdown. In the background there, you see Observatory Hill. McMurdo doesn't look too nice, and it really isn't. It's kind of crummy. It was first put together by the Navy in 1959. It used to be a Navy base, and a lot of it still dates from that time. So you just think about buildings and equipment that date from the late 50s, what they'd look like today. Well, that's what they look like. And McMurdo itself is on an island, and the island itself is made out of volcanic rock, so everything is volcanic rock underneath. Volcanic rock, volcanic dirt, or volcanic dust. So it's kind of dirty and crummy, but this is where you really have to have everything coming together for all the United States programs in Antarctica. This is your distribution center. This is where you have everything from welders to diesel mechanics to anything with logistics to shipping to food coming in to fuel coming in. Those tanks in the background store 17 million gallons of AP8 jet fuel. And everything in Antarctica for the United States basically runs on jet fuel. The vehicles, everything does. Because having one kind of fuel, you don't have to worry too much about it. But everything is there. So the first thing you do is go through orientation and training. You go through the same orientation and training every year when you land there. No matter how many times you've been there, you get the exact same training. But one of the first things you do when you first came down and find out the weather is a little bit different there. Condition 3 is acceptable weather. That's really nice weather. Could be like this, actually, but a little bit colder. But then condition 2 is where it starts getting colder, and condition 1 is where it's really cold and you're really not allowed to go outside. Visibility less than 100 feet and wind chill less than 100 degrees below zero. Now at the South Pole, it's a little bit different. You have to go outside a lot of times to do some work. So you're out in that weather. To give you an idea what the winds are like, when you have a shipping container and have to weigh it like this, down like this so it doesn't blow away. Gives you a little bit idea how the winds can get very, very high. But eventually you leave McMurdo and you get to go to the South Pole. So you're back out to the airport basically being on the ocean. And now you get on a plane that's very similar to what you came in on if you came in on a C-130. It's called an LC-130. And the difference between a C-130 and an LC-130, which is kind of a rare plane, is that you can see skis underneath. It has wheels, but it has skis too. So it can land at the South Pole. And that is flown for the most part by the New York National Guard, which is kind of amazing that the New York National Guard is flying planes down there, but they're the ones that do it. And like I say, it's kind of a rare flight to have an LC-130. Another nice flight, very comfortable. You're sitting in nylon web seats, everything's piled together. You see that kind of curtain up there and to the back? That's the bathroom. You basically pull it out around you and pee into a cup. That's what you get. And you have to climb over people to get there on a first flight. This one was not crowded because you're going to the South Pole and very few people do. Again, you fly over the Transantarctic Mountains, but now you're flying over a different part of them. And again, just gorgeous. You can see the glaciers blowing down through the mountains, and just absolutely love looking at those little portals, looking at that. And the glaciers can be really wide. The Beardsmore Glacier is 125 miles long and 25 miles wide, just constantly moving along. Finally, you land at the South Pole. South Pole's call letters are NPX, which makes no sense to a lot of people. I actually have one of the stickers on my car. You think that would be North Pole. It was actually the Navy Pole Expedition, and that's how it got its name, and it just stuck. When the plane lands, the engines keep running, the propellers keep turning. They don't shut the engines off at all when they're there. They unload it when it's running. They take the fuel off the plane when it's running. They don't put fuel on it, because when the planes come in, they fill, every time a LC-130 comes in, they fill the plane as much fuel as it can take, and then they offload it to the South Pole station so they have fuel for over the winter. So any extra fuel that they have when they get there is done. And once the stuff is unloaded, once the fuel is taken off, away they go. And sometimes they come in and they do a military offload of the equipment if they're in a hurry, where they basically open the back hatch. The plane never stops if there's no passengers on it. They just push all the cargo out the back. The plane just keeps rolling along, and up it goes again. It's gone. Pretty amazing. South Pole Station is much, much, much nicer than McMurdo. It's a relatively new station. It's pretty big. There's dormitories in it, a galley in it, but this is the main part of where you'll stay at the South Pole. The two wings on the left are dorm rooms. Third wing to the right over there is also a dorm room, but that also serves as an emergency if there was a fire. That one is self-sustaining, has its own generator in it and everything else. And the one on the right is a music room and gym and basically a recreation area. To the left of the South Pole Station area, you can see that big, we call it the beer can, that big round thing. That actually goes down below the ice. Why do you have to go below the ice? Because that brings you down there to where some really interesting things are. That's where the fuel is stored. That's where your food is stored. So there's 475,000 gallons of fuel stored under the ice at the South Pole, and that keeps them going through the winter with a little bit to spare. And that's why you're offloading those planes. There's also a traverse where they actually bring huge farm equipment, drags 1,020 miles across the ice to bring fuel in. It's also where your food is stored. I mentioned the average temperature is 57 below zero at the South Pole. Well, these rooms, being that they're below the ice, take on the average temperature. So this room is 57 below zero. So all your food is really, really deep freeze. And a lot of it is really, really old. You can get food like ice cream that's 10 years old down there. It'll be in 5-gallon buckets. You bring them up. When you bring them up, they're 57 below, so you can't scoop it out. You have to wait a couple days for it to get a little bit thawed, and then you can scoop out your ice cream. But being that it's so cold, the food, no matter how old it is, still seems to taste really good. And you do have good food at both stations. They do a very nice job of cooking. There's also a little greenhouse where they grow tomatoes and lettuce and things like that. Not very big, but during the winter, where nothing is coming in and nothing is going out, it's really, really a special thing to have. Because at the South Pole, between the middle of February and the beginning of November, no planes come in, no planes leave. It's too cold for the planes to fly in. So once you're there for the duration. You're not leaving. You're not getting any new supplies. Also, through that beer can, you get that access to the ice tunnels. The ice tunnels are about 1,900 feet. In the upper left is where the South Pole Station is, that dotted line up there, and these tunnels go underneath. These tunnels are where basically serve two purposes. This is where we get our water. There's no free water at the South Pole. You're, like I mentioned, 9,000 feet of ice. There's no water. So you have to melt ice for water. So what they do is they use the diesel heat from their jet engine powered, or not jet engine, jet fueled powered generators, the exhaust heat. to heat this water to go down in there and keep it circulating. And they end up with about a capacity of getting about 2,500 gallons of water out a day that you can use by keeping this melting. Once it gets too big, once it defrosts too much, gets too big, then it can't keep it warm enough so that you get any more water out of it. At that point, it basically becomes a septic system. That's where the sewage goes, and then they make a new one. So back on that other picture, it's where you see the different round circles are all the different ones that they have planned and are using right now. And waste heat also from those generators is also what heats the station. There's 5 big diesel, or they were diesel, but they run on APA jet fuel. 5 big generators down there because, like I mentioned, in the winter nothing can come in or go out. So you basically you only need one generator to run the station, but you have to darn make sure that you have a spare and another spare and another spare, and everything can keep running. So when you go into these ice tunnels, basically it's kind of this little cutout in all the equipment and piping and tubing, and you walk through it, and all of a sudden you're in this chamber. Basically it goes, like I mentioned, 1,900 feet through the ice, over a quarter mile through the ice. And that was cut out with chainsaws basically, and the heated tube is where the water comes through after they come out of these rod wells. And you can see here the temperature is degrees C and degrees F. You can see it's 57 below zero average temperature. We've had some pretty interesting people come to the pole. One time when I got there, Buzz Aldrin came, and that was on his bucket list, was to go to the South Pole. Well, I think this is the funniest thing. It really isn't funny, but it really is the funniest thing to me. He got altitude sickness. And I just think that's kind of odd that somebody that went to the moon got altitude sickness. So he couldn't stay. He was there for a matter of hours, and the plane we came in on, he ended up flying out on. They took him out. But some interesting things get put at the pole once you get down in those ice tunnels too. It becomes like a little place to store really strange things. Like on the top there, that fish was brought into McMurdo. It's a sturgeon, and the Russians gave it to people in McMurdo. McMurdo didn't know what to do with it, so they kept it around until it started rotting, and then they said, oh, well, let's send it to the South Pole. So they threw it on one of the LC-130s. It got to the South Pole. Somebody carved out a niche in ice tunnels and put it there. And there were all sorts of other things. There's just a couple I showed here, but basically a pig's head, things made out of tools. But once Buzz Aldrin was there, they made a shrine for him too. That was the cup he used and the tissue he blew his nose in. So that's now enshrined down there in the ice tunnels. A lot of weird stuff down there. You wouldn't believe it. The South Pole, we moved the South Pole. When you see pictures of the South Pole, you usually see the striped pole and the globe and the flags around the outside of it. Those 12 flags are from the original signers of the South Pole Treaty. But that's not the South Pole. That's the ceremonial South Pole. Since the whole South Pole is sitting on 9,000 feet of ice, it's moving. And it moves about 33 feet a year. So the Earth is not doing it, but the ice is sliding over. So the South Pole Station and everything there is sliding about 33 feet a year to the ocean. It's got a long ways to go. I think about 140,000 years before they expect it to get there. But it moves. So every year we actually move the real South Pole to where it belongs. So in January 1st, the USGS comes down there and surveys where the real South Pole is. Because the ice has moved. Okay, so axis here is here. And they put a marker. Then what we do is take the sign, we put a marker right exactly where it is, and there's a big ceremony. We pass that marker around to everybody. We pass the flag around to everybody, and that's it for the next year until the next January 1st. The station manager has a little bit of something to say. Our station manager was Wayne. Wayne was kind of a strange guy, very strange guy. He's an ex-Marine. I hear you can't have an ex-Marine, so I guess he's still a Marine if you put it that way. But he has, he's not wearing it here, but he has a coat that he got made in Russia out of wolf fur, a big furry coat. He outside every day. He walks about 1,000 miles every season during the winter around the South Pole, and he's just very unusual. He had a box underneath his desk that said raw sewage. I asked him, "What's that?" He said, "It's popcorn. I don't want anybody to take it." But the Russians actually came down and had a wedding near the South Pole. They wanted to do that. It's very expensive. It costs about $50,000 a person to go there as a tourist. So this very rich family came down to the South Pole, and they wanted Wayne to say something. Wayne said, "I don't want to say anything." This is like, oh, it's really important that you do say something. It would be good for the National Science Foundation. Please say something. So he finally agreed. He got up in front of these people and just, well, I don't believe much in marriage, but from my personal experience, everyone was a little bit better than the last, and turned and walked away. So I guess they'll never ask him again. Now, I just found out just this September, Wayne put out a book. You can find it on Amazon. It's called Cold. I have no idea how good the book is. Wayne, like I said, is kind of a strange person, but he wrote a book, and it's out on Amazon. So where did I work? I worked at really remote places in Antarctica. So we ended up on these little planes called twin engine otters. We'd get all our stuff together, pack it on, pack it in a plane, and up we'd go. And we fly up to 660 miles away from the South Pole Station. It's beautiful desolation. When you're flying over there, you just see nothing. Nothing. There's not a rock, there's not a twig, there's nothing as far as the eye can see. I love it. But these planes get about 2.5 miles a gallon. They fly at about 150 knots, about 150 miles an hour, I think it is. So they're not really fast, but they're really sturdy planes. But you have to stop and get fuel every now and then. So to get fuel, what happens is the LC-130s fly overhead, and they drop barrels of fuel down with parachutes. Then somebody goes out there with a plane, gets all the barrels together and puts them together into a fuel cache. And then you get these using your GPS, you figure out where these barrels of fuel are, you go down and you pump them into your plane, and away you go. This is a picture of where I work. This is one of the stations. We have EGO 1, 2, 3, 4, and 5. We also had EGO 6, but we weren't able to get to it for quite a few years, and it was too near the shore. And the meteorologist says it's probably under about 70 or 80 feet of ice now, so it's gone. But we dig these out when we go to them. So this is EGO 4. We get there, we get on the ground, get out of the plane, take our stuff out, get into that little box, that 8 by 8 by 16 box, melt some ice for water, cook some food on a little cook stove, and work on all the instrumentation there. Set up weather stations if we have them to get them going. You can kind of see what the terrain is there is nothing. I love it. I absolutely love it. Organized caches. We have caches around there of food. We have cache of fuel, and we have a cache of equipment. And then when we're done, we can be there for as short as 1 day, but usually about a week. We set up tents and work out of our tents. Away we go. We fly. They call the plane. The plane comes in. You can see it coming in the background to pick us back up, and away we go. So I brought Hope to the South Pole. I brought a Hope t-shirt, and at the real South Pole, put it on and had it there. But you can see the weather can get really cold. Early fall, 71 degrees below zero. I think today when I looked it was 68 below, 109 wind chill. And on cold days, very, very cold. Also, your perspective about temperature gets really warped. As you can see in this little newsletter here, it says the weather briefly turned milder after the storm, with temperatures approaching minus 30 degrees Fahrenheit. So that was mild day. So back to McMurdo, back on the LC-130. Get back there, get on these weird vehicles left over from the Navy in 1959 and 1960s. Really odd things that you get on. But now we have a problem. We have to go to EGO 5. EGO 5 we go to out of McMurdo because it's too far away from the South Pole for a twin-engine otter flight. So you have to be acclimated to altitude. So we are at the South Pole, we're at 9,100 foot altitude. We're acclimated to the altitude. We go down to the ocean, basically, at McMurdo. We get on another plane and we fly to EGO 5. Problem is, the weather was bad, so we weren't able to do that. So we ended up stuck at McMurdo for 5 days. So you're not acclimated to the altitude anymore. So you can get altitude sickness, and they don't want you to go out there since we're leaving you out there. They don't want you to go out there if you're going to get that. So basically what they want to do is get you acclimated to the altitude again. Well, how to do that? Well, pretty easy. There's a volcano right near McMurdo. It's about 25 miles away, called the Erebus volcano. It's the southernmost volcano in the world. It's an active volcano. It's one of only 3 in the world that has a lava pool on the bottom. It's been there since at least 1970, that lava pool. So we get picked up with a helicopter. We get flown out there. They drop us off on the volcano, and we set up our tent. You can see our tent sit there. and we lived there for 4 or 5 days in those tents at altitude. But now we're about 10,500 foot altitude. But it's like I said, it's an active volcano, so you can go up to the top and you can look over the edge, and yeah, lo and behold, it's an active volcano. It's really blowing up stuff, and it hasn't thrown out lava balls since I think the 1980s, so you don't really have to worry too much about that. But eventually, the helicopter comes back, and now they do that when the day is clear and everything's ready. The plane's ready. You can definitely go to Ego 5. Take you to the airfield. As you can see here, it's on the ocean. It's just basically frozen ocean. Get on another plane, and away you go. Again, stop, dig up your fuel, take your empties with you in a plane, and go to Ego 5. This map basically shows how you go to the different sites. Ego 5 is about 660 miles away from McMurdo, and you're flying basically from Mount Erebus to the airfield to Ego 5. Work there, and away you go. I put Concordia Station on this map because now we go there instead of going to Mount Erebus. We go to Concordia Station, which is also at high altitude, and we stay there in an actual real station, a French-Italian station, and then go from there. It's only about a few hundred miles to get to Ego 5, so it's no problem. The whole map of the different places we go. It's kind of interesting. As I mentioned, it's about 1.5 times the size of the United States, so this really involves a lot of travel. And it's gorgeous. It is gorgeous. I recommend anybody, if you have a chance to go, go. You can actually get jobs down there. It's not really much of a problem. There's quite a waiting list for different things. But I mean, they need everything from janitors to cooks to welders to diesel mechanics to, doctors, you name it. Actually, it was kind of funny. At McMurdo Station, there's what they call the hospital. It's just kind of a big box. And they actually have a dental chair in it. And a few years ago, I got to know the nurse. A few years ago, a guy came in there and he had an abscess so bad they had to pull a tooth. And he sat in that chair and he says, the guy came in and he goes, I got to tell you, he says, I just petrified of dentists. I just always been really scared of dentists. And the guy looked at me and he says, that shouldn't be a problem then. I'm not a dentist. And pulled his tooth. So yeah, there's a little bit of dark humor there. But how do things get there? I mentioned a traverse. I'm not going to show you things about that. Traverse is pretty amazing what they take from McMurdo to the South Pole. But how do things get to McMurdo? Well, the shipping starts with an icebreaker. The United States has exactly one working icebreaker right now. I think we're in plans to make more, but this one is the one. It's called the Polar Star, and it breaks almost every year it goes down there. Something goes wrong with it. But it has to break through the ice to get to McMurdo at the beginning of the warm season. And it has a lot of ice to break. So here's where you can see where it came through, and then it takes its turn and goes to McMurdo. Next thing comes in is the cargo ship, which brings in all the supplies and all the building materials and all the new scientific instrument. And it also takes out all the garbage because there's no place to put it there. So it all goes back in containers and gets shipped to California, not New Jersey. Then a fuel tanker arrives to fill up all those 17 million gallons of fuel at McMurdo, keep them filled up. And here's the icebreaker, came in right next to the Coast Guard, and they tie up there. It was pretty amazing. So finally, our trip was basically over. Now we get on a C-17, and we fly off to New Zealand. Two flights ago, it was pretty amazing. We were there, and we saw the Antarctic firemen out there with brooms running around out in the field. We couldn't figure out what they were doing. The penguins got out on the runway, and they were trying to shoo them off. And those penguins can get really big, 4 foot tall for the emperor penguins. They can get actually that tall. They're pretty amazingly big birds. They're not afraid of people, and they're apparently not afraid of brooms. They're just very curious. That's what you are. So we sat on the plane. That was before the plane came in. The plane was going overhead, and we couldn't figure out why it was going overhead like this, back and forth, circling around, because they were trying to get the damn penguins off the runway. The plane could land. Plane landed, and away we went. When you get on a C-17, full C-17 definitely beats a C-130. As you can see, there's a lot of room. You're not all leg interlaced and everything else. Well, that is the end of my short presentation, and I hope you enjoyed it, and I hope you enjoy the skies tonight. They look wonderful.
All right. Thank you, Gil.
If you
So,
have any questions, I'll take them at any
yep,
time.
we are going to be doing a Q&A. I did notice a couple people sneaking in, so I'm going to just briefly go over the safety things again. Again, if you do need the bathroom, it's the porta potty to my right, your left. We have the gift shop and museum area. To my left, your right. When we go to leave, we use our headlights. We like not getting run over. I'm sure you also feel the same way. That being said, if we have lights to walk around, because as you notice, we are lacking a moon. I think it's a new moon
Yeah,
tonight.
beautiful.
Just keep them pointed down towards the ground, just so that we can avoid people being unnecessarily blinded. Now, on to the questions. For those people here, you're going to have to raise your hand and kind of wave it out because I am kind of blind in the night because I end up looking at a screen. I am going to start with us off with one of the questions from our online audience because they were here tonight. So, where'd it go? Oh no. If you put a thing of popcorn that you would use like in a campfire on the microwave dish, would it pop?
No, it would not. Basically, the power coming in from microwave is so infinitesimally small. As I mentioned, it's about 2/10,000ths of a degree difference in temperature that you're looking at the difference. So it's very, very small.
That's slightly disappointing. You hear microwave and you're like, oh yes, popcorn. All right, I know there was someone waving their hand out. All right, I'm gonna go to the really excited person first.
Can you see like animals like penguins and walruses and polar bears there?
When you're in McMurdo, yes, you definitely do. You'll basically see penguins. There is Adelie penguins, which are maybe 2 foot tall, up to emperor penguins, which can be 4 foot tall. They basically follow the edge of the sea ice. So as the sea ice is melting over the summer, they're following that edge because then they jump in and get their food out of the ocean. You'll also see seals, and seals basically come even earlier than the penguins. Once the sea ice starts breaking up and there's any kind of cracks or holes in it, they'll come out and basically but basically lump across the ice and just sit out in the sun for a while. I never really understood why they'd sometimes go hundreds of feet from the hole. They're just laying there, and then they'd go back and go down again. You'll also see killer whales later in the season. They come through. You'll also see birds. There's snow petrels, which are rare to see. They're a white bird. Actually saw one of them in 8 years. I only saw one. But then there's skua, which are birds that are kind of like a supercharged seagull. They're bigger, they're stronger, and meaner. And they will take food from you, and they tend to work in pairs. So if you come out of the building in McMurdo and you have food like a plate or something, one will come and actually whack you, so startle you, so you drop your plate, and then they come back and grab the food, and off they go. Funniest thing I saw was a guy that had a bag of potato chips, and he had it open, and he reached in, he grabbed one potato chip out, and he had it like this, ready to put it in his mouth, and a bird took it right out of his hand. And he's looking up like this, and another bird took the whole bag. So when you take food out of the station, basically what you do is take another plate, put it over the top, then put saran wrap and wrap it around that. So if they knock it out of your hands, you can just pick it up, laugh at the birds, and keep walking. So you'll see them. In the ocean itself, there's some really phenomenal stuff. As far as there's a dive tube that they'll put down in the ocean, which will cut through the ice, that you can actually go down about 15 feet through the ice into a little plexiglass room, which is just about big enough for you, and watch the seals and the things that are under the ice, the fish and the sea spiders and everything else like that. Really kind of cool. But once you get away from McMurdo, there's
sea spiders.
Once you get away from the McMurdos, there's no life whatsoever.
All right. So our next question from online was about the Event Horizon Telescope. How did they choose observatories to be part of the Event Horizon Telescope? Or was there like a sign-up sheet where people were like, yeah, I want to be on this?
Well, to get that resolution, basically what they wanted is telescopes that, well, first off, could read in the microwave range that they wanted to read. And the second thing they wanted is as far apart as they could. They're trying to get a big baseline. So the South Pole is pretty much as far apart from anything as you can get. So that's why one of them is there, and then the other ones are at different places where you have good viewing, the right kind of telescope that can look in a microwave wavelength, and far distances between them, so you get that fine resolution.
All right. I know you had a question.
Yeah. How did you acclimatize yourself to go there, like physically and I guess mentally as well?
How did
How
I?
did you prepare yourself? Like,
Oh, well, basically, you go through a physical qualification, which I probably couldn't pass anymore. I had a back operation. Um, you go through a physical qualification where they basically test everything about you. Test your blood type every year, which your blood type doesn't change, but they test it every year. But they test you for just about every disease, every kind of thing you could have wrong with you. You get on treadmill, they test your heart rate, you get EKG, sometimes you get a chest x-ray, but you go through that every year to see if you're physically qualified, because there's not really that much down there in the way of medical care. They figured to get you to a hospital, if you're at one of the EGOs, could be actually longer than a week, easily longer than a week. So they want to make sure you're going to not break while you're down there. Basically, I just did, for the most part, did a lot of walking just to make sure that I was physically ready to go down. Not too bad, not too bad. But I like cold weather, so that was kind of good for me.
Yeah,
As
he
you
would
can see,
come
I'm
back in
in my t-shirt
February,
now, so I'm
shorts and
absolutely
t-shirt,
fine with
and
it.
just be like, "Man, it's hot." All right, that actually leads us to our next online question. Were you going back to
I
Antarctica?
don't think I am, and that's very unfortunate. I've had 2 back operations, and I have Parkinson's disease. So between all those things, and some of the funding for one of our remote programs was also cut. So I don't. I think that's probably it for me. But I'd go down there and drop of a hat. I just absolutely love it there. Um, the last time I went there, I was there for I think about 3 months, and it was fantastic. It's just a fantastic place to be.
All right, is that a hand I see over there in that corner? I'll be back to you, okay? Or did I lose it? Oh no.
By the way, the back operations, my wife says, because of years of stupidity.
Were there any flushing toilets there?
Yeah, at the stations there are flushing toilets. At South Pole Station there are flushing toilets, and you take showers. They get the water out of those Rodwells. You're allowed 2 2-minute showers a week, and that's it. But it's very dry, so you don't really sweat. Um, no big problems there. There are even washers and dryers there. So once you're at the EGOs where I work in the remote field, no, there's no flushing toilets there. But basically, what we do is dig a big hole in the snow, put a Scott tent over the top of it, crawl into the Scott tent, and there's your toilet.
All right. Also, great lead up into the next online question. What is there to do in Antarctica when you're not working, like any indoor recreational activities? Uh, and it looks like you answered half of these questions because they were thinking that with resupply being limited, activities would also be limited.
Now, actually, there's quite a few activities. Obviously, well, there's cross country skiing. There's a lot of hiking people do. Um, there's all different kind of clubs there too for people, like for different games you want to play. South Pole, for instance, there's dodgeball, which gets unbelievably mean. It's just really amazing to watch them throw a ball at each other really hard. There's dodgeball. There's a music room where there's all sorts of instruments. There's libraries. There's a room for doing kind of crafts, for all kinds of craft supplies. Many different things to do there. They also have races. They actually have a marathon at the South Pole, full marathon. I can't remember the time it takes, but it takes quite a bit longer because you're at altitude, a lot lower oxygen, and you're running on ice and snow. But there's quite a few people that do that. A half marathon there. There's all different types of activities like that. Even in around Christmas time, people build gingerbread houses, and a lot of different things to do. And there's all sorts of stuff you can volunteer for down there too. You can work with the carpenters, for example, if you're bored, or work with the electricians, or just help clean the station. A lot to do all the time.
All right, our next question's over here.
My
Oh.
dad went to Antarctica, and can you see macaroni penguins in Antarctica?
Can I?
Did you say macaroni penguins? Are there macaroni penguins in Antarctica?
I don't think so. I haven't heard of them.
I'm thinking there's a. Do you know the breed he's talking about? The species?
Like they have those yellow hairs on their head.
Apparently, the ones with the yellow spiky afro,
Oh,
uh,
they're
not afro, mohawk. That's the one I'm thinking of.
okay. That sounds like the emperor penguins. They have that yellow top of their heads. Kind of cool looking things.
Also, you said emperor penguins were like 4 foot. I just realized that's a bird that's up to my shoulder. I'm only 5'3". Marconi.
Oh, okay. Thank you.
Yes. I'm like that's a mistake I would definitely make, so I don't blame you.
No, I have not seen a Marconi penguin. I don't know about those, but that sounds pretty cool. I've got to look them up myself. Thank you.
Thank you, Chris.
Yeah, thanks a lot, Chris.
There's a reason why I keep the guys around. All right. Our next online question is, how did they handle COVID with Antarctica?
Oh,
You
it
know,
was-
they're so remote, and you said you were getting there through New Zealand,
It was
which
horrible.
closed during the worst
It
of
was
it.
horrible. First off, the last trip I went was 2019, 2020. So I came back in 2020, right around the start of the COVID stuff. Let me put it that way. It got really tough after that. Basically, they shut down everything to do with National Science Foundation going to Antarctica, except for things that were really essential. All construction stopped. All science projects basically stopped. Some science projects fell apart because they had to be constantly manned and weren't able to get manned. Last year, even that was 2020, 2021, 21, 22. It was so arduous to go down there. Basically, you had to quarantine in San Francisco or Los Angeles for I can't remember how many weeks, and then you flew to Christchurch and you had to quarantine in your hotel room in Christchurch for a week, where they'd leave basically food outside your door, as far as I understood it, and you were allowed a half an hour a day for exercise. And then you got to fly to McMurdo and you had to quarantine there, and then they'd let you go South Pole for 6 days. So none of our group went. This year, I have really no idea if anybody is going. It really shut things down tremendously.
All right. Another question. Yes.
Were you able to view the South Pole telescope images live while you were there, or is it something that takes time to process?
No, you really don't get images. You basically get data from it. So basically, they use I can't remember how many petabytes of data they collect on that, but basically all the data is logged to hard drives, and then the hard drives are really sent to different observatories or different computing centers in the United States to get decoded into the different images that you get from it. So there's no viewing at all. It's basically just all recording data in microwave wavelength.
All right. Was there another question here? All right. While I'm waiting for someone to think of another question, the next online question was, what is the oldest food you have eaten in the South Pole?
Apple juice from 1995. It wasn't bad. It really wasn't bad.
I'm sure at that temperature you had no fun things happening.
No, actually,
That
but
usually happens with
I know that
aged
date because I was
juice.
so amazed we took a picture of it.
All right. Questions? All right. Next online question. Has there ever been a change in the rate or direction of travel of the South Pole? Like you said, the South Pole's
No,
leaving.
actually, it's pretty much going in a straight line. It does about 33 feet a year, pretty much in a straight line, because it's basically following the contours of the continent underneath. So the ice sheet basically is moving along that valley. If that valley, which I don't know really where it is or what it's shaped like, if that valley changes shape, I'm sure it will start changing again too. Where those types of things happen, or where the elevation of the underlying snow or underlying continent changes by a great degree, that's where you start getting crevasses in the snow, which can be really dangerous to travel on because they go down hundreds of feet. And yet the tops can be solid, but only a foot or two thick. So a vehicle hits it and gone, down right through it. Not too many years ago, one of the scientists on a snowmobile fell into a crevasse and died.
All right. Questions from our audience here? Again, I'm kind of blind because I've been looking at a screen, so it might take some motion. Oh, I see one. You guys laugh when I say I'm actually kind of blind at night, but
Do you have any problem dehydrating food? Any problem dehydrating food? Sorry.
Well,
Do you have problems dehydrating food?
dehydrating?
Or did you mean defrosting? She wanted to know, have you ever dehydrated food while you were in Antarctica?
No. Basically, I don't really think I can't think of anything that we had that was dehydrated. Everything we have is frozen. Absolutely everything. I mentioned the ice cream. The ice cream is so hard that if you want to eat it right away when you take it out of those tunnels, best way to do it is put a spade bit on a drill and drill into it. That'll kind of whip it up enough that you can scoop it out.
All right, we got another question here.
Yes, does the cell phone work in South Pole?
Want to repeat that question?
Does the cell phone, cellular phone works in a wireless phone works in South Pole?
Do the cell phones work in the South
No.
Pole?
No, there's no cell phone service at all. In fact, to communicate from here, there's some antennas on the roof that get here some of the data from the South Pole. It's all through satellite. We have the Iridium satellite constellation, which flies 240 miles up, 244 miles up, and it's a north-south orbit. And we have satellite phones that can talk to the Iridium satellites, and the Iridium satellites pass them from one satellite to another until we get down to an Iridium phone here. And we also have basically equatorial satellites that are 5 degrees above the horizon from there, and that's how we get our data. We actually pull data here every day from the South Pole. I just did a little while before I came up here. Everything's done through that. We have IP phones that will also work through those satellites, but you get a limited time during the day that those satellites are visible.
All right, I'm just putting out a last call for our online audience to get any last minute questions in. Chris, who helped us out with the penguin question, also mentioned that they just got Starlink at McMurdo. So
I missed that. What?
Chris, who helped us with the penguin question, said they now have Starlink at
I'll
McMurdo.
be darned. Okay.
So yay. You know, small victories. So while they're getting in their last questions, the next question I had was, is there a point at which AGO 6 might become discoverable again, or is it just like done?
It's gone for good. To get down to it, the snow there is not like snow here. You don't dig it with a snow shovel. You basically end up sometimes even actually using a saw to get down to it. So it's done. First off, the AGO program is basically defunded at this point, and AGO 6 is so far down in the snow, just to find it would be trouble because it moves with everything else, and it's like 70 feet down, so it would be very hard to detect where it is and then dig down to it. It would just be impossible.
All right, next question.
Are there electricity in Antarctica?
Electricity? Yes, everything's done by generator. So there's generators down there. McMurdo is kind of interesting because they actually have a flywheel that spins at a high rate of speed. It's a huge flywheel. So if they lose power from it and have to switch over to another one, the flywheel can keep that whole big area, that whole kind of town, working for enough seconds for another generator to kick in. But everything's jet fuel generators for everything. I did mention the water in Antarctica. The water at South Pole is melted ice. The water at McMurdo is not melted ice. The water at McMurdo is desalinated seawater.
That actually answered one of the online questions because they were wondering about the electricity as well. The next one that wasn't that electricity question was, do you ever point of safe return back to Antarctica like you will do for New Zealand?
Did I miss that?
So you mentioned going to Antarctica, there's a point of safe return.
Right.
Do you ever have that situation going the opposite direction?
No, because basically a couple of reasons. First off, the weather doesn't get that bad. Well, it can get pretty bad, but it doesn't get terrible bad in New Zealand. And the second thing is you have alternate airports. So if it's bad at one airport, you can land at another, whereas going to Antarctica, you can't. In fact, interestingly enough, one of the fields there was a plane that used to be called the Constellation. I think it was, I can't remember the date, and it was in the 70s, flying there. And they flew past the point of no return, and the weather turned bad in McMurdo, so they had to land. And they actually landed there, and there was big snowdrift in the middle of the runway. Perfect landing, but it hit that snowdrift and actually ripped one of the wings off the plane, and that plane's still out there on the ice. And that's called the Pegasus. They named the airfield after it, the Pegasus.
Right. Is there another question from our? I think I see one all the way back there. You might have to keep your hand up because there's many of you and one of me found you.
We missed the first couple minutes, so sorry if this was already answered. How much international collaboration is down there? Is it all Americans or people from all over?
It's mostly Americans. It's American. Both those stations and Palmer Station, which are 3 stations from the United States, are all American stations. But you have a lot of people from different countries coming in because of the universities. So different people at universities from different countries. American universities will also be down there. Right now we're working with South Korea, trying to build basically one of those AGOs, one of those automatic geophysical observatories, build one of those that are portable, that can be easily put out in a field somewhere to record data. So yeah, you do see people from other countries all the time, but for the most part, it's mostly Americans.
Right. And that actually leads into really well into a different one. If students go down, what do students usually go down to Antarctica for?
Basically, usually you have graduate students or postdocs going down there to work on their instrumentation on the different things. For example, the South Pole Telescope, there'll be a lot of students going down there to take data, learn how to do things, design different things. You have students all over the place working on things.
All right. Was there another question? All right. So the next online question, and I coming here down to the end of the online questions, with the ice constantly shifting, how do you deal with the potential foundation issues, especially with such as leveling a telescope?
Well, a telescope I don't think has been having much of a problem. We're working at 33 feet a year, but the issue is we're on 9,000 feet of ice, and that's pretty stable ice. It's moving, but it's moving as a solid mass for the most part. The telescope, if it shifted tremendously, there'd have to be compensated for. But considering that the telescope itself can move and aim it anywhere it wants, a little bit of movement wouldn't make much of a difference.
Right. Oh, there's a hand.
It's where the crevasses are that it's a real problem.
All right.
When was the last time the volcano erupted?
I think I think it was the 80s, late 80s. It threw out lava balls, but that was the last time I think it actually erupted. There were some huge eruptions, but they were thousands of years ago.
Right. So one of our last online questions, and again, if there were any more online questions, I do suggest you get them in. Other than the shallow areas you can look under the ice, do you know if there are any spots that are more in the deeper snow and ice under the massive Antarctica, or would those be scientific outposts then?
I kind of missed it a little bit.
I have no idea where they were going with that question either. I was hoping you might know.
I can tell you under the ice they detected lakes, and it looks like a lot of these lakes are kind of interconnected way down there, miles down through that ice. They're very interested in seeing what is living down there, if anything. That's one of the interesting things about it that they're working on now.
I thought there was a B-rated horror movie about things living in Antarctica lakes.
Yeah.
Any last minute questions from our audience here? Anything? All right.
Well,
So
thank you very much.
I want to thank everyone for coming out, both our in-person audience here and online. I want to thank you, Guilford, giving another wonderful presentation and coming back. And everyone, have a good night. Have a safe drive. And like I said, there are observatories open. Each little shed with the roll-off roof has a telescope, and all the observers here would be happy to help you figure out what they're viewing, because it is gorgeous. Have a good night. Bye.